Hi everyone! Welcome to our learning activity video for Senior High School General Mathematics Learning Activity Video Quarter 2 Melc number 5 or Most Essential Learning Competency number 5. For the objective, the learner is able to illustrate simple and general annuities. There are many practical examples of financial transactions involving installments. And these are car loan, being repaid with equal monthly installments. Another is a retiree purchasing a pension plan from an insurance company upon his or her retirement. Others, we have a life insurance policy being purchased with monthly premiums, and a bondholder receiving an income in the form of semi-annual coupon payments. These are examples of payment by installment, which are done periodically and in equal amount. The payment scheme is called annuity, which can be used to accumulate funds. Examples are making regular deposits in a savings account or making payout funds. Example, when someone receives payments from pension plan after retiring. Annuities according to payment interval and interest period can be classified into two ways. And these are simple annuity and general annuity. So we have important terms. Annuity, denoted by capital letter A. It is a sequence of payments made at equal or fixed intervals or periods of time. For payment interval N, this is the time between successive payments. Term of an annuity denoted by letter T. This is time between the first payment interval and the last payment interval. So say for example, for 5 years or 10 years or 8 months. Those are term of annuity or time T. Regular or periodic payment denoted by capital letter R. This is the amount of each payment. Then the amount or future value of annuity denoted by letter F. This is the sum of future values of all the payments to be made during the entire term of the annuity. And for letter P, capital letter P, present value of an annuity. This is the sum of present values of all the payments to be made during the entire term of the annuity. Simple annuity, we have an annuity where the payment interval is the same as the interest period. Say for example, if the interest period is say 4% per annum or per year, and you have to pay it installment by year, so that belongs to simple annuity. Then we have the general annuity, in which case an annuity where the payment interval is not the same as the interest period. Then we also have ordinary annuity, or sometimes called annuity immediate. This is a type of annuity in which the payments are made at the end of each payment interval. Annuity due. This is a type of annuity in which the payments are made at the beginning of each payment interval. And annuity certain, a type of annuity in which payments begin and end at definite times. Contingent annuity, an annuity in which the payments extend over an indefinite or indeterminate length of time. For simple annuity, we have example number 1. Suppose Rodrigo, a high school student, would like to save 5,000 pesos annually in a fund that gives 10% compounded annually. How much is the amount or future value of his savings after 4 years? So this is a simple annuity because we have here the interest is compounded annually and the term of payment is 4 years, but he has to pay or deposit 5,000 pesos per year annually. So simple annuity, in which case the interest period is equal to the payment period. So for the solution, we have to illustrate the cash flow in the form of a time diagram. So we have here the time diagram. We have 0, 1 to 4 in terms of years. And for each term or each year, we have, or Rodrigo has to pay 5,000 pesos. Okay, so this is his first payment in the first year. Second year, same amount. Third year, 5,000 also. And in the fourth year, it's also 5,000. So maturity value, compounding M times a year. So this is F, maturity or future value. This is equal to the P or the present value times the quantity 1 plus I raised to M all over M, raise it to M times T, where we have F is the maturity or future value and P is the present or principal amount. I raised to M is the interest rate or annual rate. M is the number of conversion period, frequency of conversion, and T is the term or time in years. So given we have the principal amount of 5,000, then the term T equals 4 years compounded continuously, and frequency of conversion per year we have at M equals 1 because it's yearly. Annual interest rate I raised to M equals 10%, so converted to decimal is 0.1. And we have to find the amount or the maturity or future value at the end of the term, which is 5 years. So in this case, we have F. We have the formula, so we substitute principal amount P for 5,000. I raised to M is 0.1 and M is 1. And of course, this one here. So to simplify, we have 5,000 times the quantity 1.1 raised to T. That's the simplified formula for this particular problem. The second step is to find the future value of all the payments at the end of the term T equals 4. So we have here the time diagram, 1 to 4, then each is 5,000, and for each year, say at the end of 1 year, we have the formula is, we have here F equals 5 times quantity 1 plus 0.1 all over 1, raise it to 1 times 0, the T. So we have 5,000. After year 2, we have 5,500. Then year 3, we have 6,050. And on the fourth year, the future value is 6,655. Now, if we sum up this 5,000 plus 5,500 plus 6,050 and 6,655, this is the amount of savings of Rodrigo. So let's sum up this. We have future value is 23,050 pesos. Hence, Rodrigo will have 23,050 pesos in his fund after 4 years. So we move on to the exercises. We have here the general directions. Let me read. In answering the exercises in the learning activity sheet or the LAS, please be reminded not to write anything in the LAS. All answers must be written in a separate sheet of paper. Read each problem carefully and answer it systematically. If solution is required, encircle your final answer. For exercise number 1, Miriam borrowed money and promised to cancel her debt of 5 years by paying 3,500 at the end of each year with interest at 4,000 compounded annually. Okay. So, letter A, draw and fill in the box to complete the cash flow time diagram Miriam should follow to be able to reach her goal. So, let's fill in the time diagram. So, how many years we have 1, 2, 3, 5. So from 0, year 2, 0, year 1, year 2, year 3, 4, and 5. And this is each term is 1 year. Okay. And how much is the payment for each year? It says 3,500. So this is the cash flow time diagram of Miriam. Say for letter B, Miriam changed her goal and decided to pay 4,000 at 4% compounded semi-annually. So instead of yearly compounding, we have here the same 4%, but it is compounded semi-annually. That means twice a year. Complete her new cash flow time diagram. So again, let's start with the P, or the present value, and the future value for years. Then from 0 to 5 years still. The changes are from the first one are this one. The compounding period, instead of annually, it's semi-annually. And of course, the payment, instead of 3,500, it becomes 4,000. So this is the answer. And let's move on to the guide questions. For number 1, what type of annuity is being described by the cash flow time diagram in exercise 1A? Well, simple annuity, as this refers to an annuity where the payment interval is the same as the interest period. Number 2, what type of annuity is being described by the cash flow time diagram in exercise 1B? Well, it's general annuity, because in this case, the compounding period here is semi-annually, and the interest period is yearly. Okay, so general annuity, it is where the payment interval is not the same as the interest rate period. Number 3, what are the important data that you need in illustrating annuity? Well, possible answers here, knowing whether it is a simple or general annuity, then payment interval N, term of annuity T, regular or periodic payment R, then interest rate. So those are the things that we need to consider in illustrating annuity. For exercise number 2, study and illustrate the cash flow time diagram of the annuity being referred to by the following problem. Peter started to deposit 5,000 monthly in a fund that pays 1% compounded monthly. How much should be in the fund after 8 months? Take note here, we assume that the interest rate period is 1% per month. And the compounding period is also monthly. Okay. And for letter B, Anne's parents are planning for a house lease agreement. How much money will they prepare in a house that has 6% interest rate compounded semi-annually in order to pay 30,000 pesos annually for 5 years? Oh, there must be some question mark here. But anyway, I highlighted in yellow this one. There was a typo error in the learning activity sheet. So to make it correct, we have it here. Okay, so let's answer first exercise 2A. So these are the given in exercise 2A on the problem about Peter. Periodic payment R, this is 5,000. The term T is 8 months. Interest rate per month is I raised to N is 1%. So we make it 0.01. Then the number of conversion period in a month is of course N equals 1. And we have to find the amount, or F, the future value at the end of the term. So here's the formula F. And this is equal to the R. R is the payment period. And this is 1 times R times 1 plus I raised to N over N, close quantity, raise it to N times T. So plugging in the values given, 5,000 times quantity 1 plus 0.01 divided by 1, close quantity, raise it to 1 times t. So to simplify this formula, it's 5,000 times 1.01 raised to t. And t is 8 months. So we have to illustrate here using this formula, we have to use it 8 times. Earlier, we have used the forward method of calculating the future value. In this case, we will use the backward. We will start with the 8 months. Since here, this is the payment period for the 8 months. So in here, the formula is just, why is it 5,000? Well, let's assume that at t equals 8, t is equal to 0. So the whole thing at t equals 0, at the 8 months, there's no more next month. So t equals 0 here. So we have 5,000 times 1.01 raised it to 0. So that makes it, anything here raised to 0 is 1. So 5,000 times 1, that makes it 5,000. Then, at t equals 7, that means 8 minus 7 is 1. So that's 5,000 times 1.01 raised to t equals 1. And we have here the amount 5,050 pesos. At t equals 2, we have 5,100 pesos and 50 centavos. At t equals 3, we have the formula. Following the formula, for t equals 3, we have 5,151.51. At t equals 4, we have 5,203 and 2 centavos. Then we have, at t equals 5, we have 5,225 pesos and 5 centavos. At t equals 6, we have 5,307 pesos and 60 centavos. And at t equals 7, we have 5,360 pesos and 68 centavos. So let's collect all the payments made 2, 4, 6, 8 months. So we have the sum is 41,428 pesos and 36 centavos. Hence, Peter will have this amount in the fund after 8 months. Okay, exercise number 2. As parents are planning for a house lease agreement, so I have read this earlier. So take note of the semi-annually and highlighted in yellow, and this is annually. So this time, it's the reverse process because we are given the future value and we have to find the present value. Okay, so we started with the formula F equals P, or sometimes it's written here R. So you can either use P, capital P or capital R. In this case, we have capital P, this is the principal amount, times the quantity 1 plus I raised to M, the interest rate period, over the conversion period M, close quantity, raise it to M times the time. So we have to convert or isolating this P in terms of F. So we have it here. And finally, since F is given to be 30,000 and 1 plus the 6% I raised to M. But M here is 2. Why 2? Because in 1 year, we have twice conversion. So raise it to 2t. M is 2 times t. So we have this one. Next is to formulate the time diagram for this particular problem. So we have 5 years terms of payment. Then it's semi-annually. So that means the payment period is, the compounding period is every 6 months. But the payment is every year. So, and the amount paid every year is 30,000. Now, the concern here is how much is Anne's family will prepare, the money that they are going to prepare in order to push through with that house lease agreement. So we have it here. Let's recap again the time flow. Let me make this more faster. Okay, so let me discuss this first. At the end of 1 year, since F is equal to 30,000, so we have the formula here. 30,000 divided by 1.03 raised to 2 times 1. So that is 28,277 pesos and 88 centavos. Then at the end of 2 years, or the second year, t equals 2. Just plug in the formula and the values here, substitute it at t equals 2. So we have 26,654 pesos and 61 cents. On the third year, we have 25,124 pesos and 53 centavos. At t equals 4, we have 23,682 pesos and 28 centavos. And at t equals 5, we have 22,322 pesos and 82 centavos. So summing this up will give us the amount that Anne's family need to prepare. So we have it here, 126,062 pesos and 12 centavos. So we have here the present value P. And hence, Anne's parents will prepare this amount for a house lease agreement. If you are not yet a subscriber of my channel, kindly subscribe and please don't forget to like and share. And if you are a subscriber, you will be updated with more uploads for these learning activity videos. Thank you and always stay happy, healthy, and safe. Bye!